Code blue, code blue. We have a C program crashing in the ER. The patient was trying to parse some data, but it's having a memory access violation. Let's look at the patient's chart. The code is trying to print out an array of integers and then copy a string. But there are two big problems here. First problem. The check for the end of the array. The developer used sizeof of values to get the size, but values is an integer array. But sizeof of values returns the number of bytes, not the number of elements. The pointer is an integer pointer. So when we add sizeof of values to the values pointer, the compiler scales it by the size of an integer. For a 5-element integer array, the array is 20 bytes. Pointer plus 20 jumps 20 integers ahead instead of 5. This is a buffer overflow waiting to happen. Second problem, the string copy. The message contains the word hello. That's 5 characters plus the null terminator, so 6 bytes. But the buffer is only 5 bytes. This is a classic stack-based buffer overflow. It's like trying to fit a 6-foot patient into a 5-foot bed. The data spills over and corrupts other memory. Think Splinter. Where does it spill? Right into the adjacent memory on the stack. This causes unpredictable behavior, and in this case, a crash. Time for surgery. First, we fix the pointer arithmetic. Instead of sizeof of values, we use the number of elements, which is 5. This way, the pointer stops correctly at the end of the array. Second, we increase the buffer size to 10 bytes. Now there's plenty of room for hello and the null terminator. No more overflow. The patient is stable. We fixed the pointer arithmetic bug and the buffer overflow. The code runs perfectly. The lesson? Always know the difference between bytes and array elements. And always make sure your buffers are big enough for your strings. Find the bug number 4 is coming soon. Send me your buggy code and I might diagnose it in the next episode. This is the Code Surgeon, signing off.